video, let us discuss about pre-processing in NLP. So what is NLP? NLP is nothing but natural language processing. So why it is really required to understand natural language processing, right? So we are trying to teach the computer to learn languages, and then also we expect that to understand it with suitable, efficient algorithms, right? So we may be familiar with the Google's keyboard, which suggests autocorrect or word predict and more, right? So there is another tool called as Grammarly, which is a tool for content writers and professionals, and it makes sure their articles look professional. So how does it work? It uses YAML algorithms to suggest the right amounts of vocabulary, or it could be tonality, and it could be much more than that, right? So that the content is written professionally apt and it captures the total attention of the reader. And the next one is about the translation systems that use language modeling to work efficiently with multiple languages. So why do we give more importance to this NLP nowadays, right? So we all know that people are nowadays involved with the languages and they are trying to understand the patterns in languages, which are called as linguists, right? So Wikipedia is the greatest source for that, right? So the field of computational linguistics began with an interest. It tried to understand the patterns in data, or it could be parts of speech tagging, easier processing of data, various applications in the banking and finance industries. It could be educational institutions, and there are many more, right? So how does this work? So what it does, how does this NLP basically work? So it converts the unstructured data into computer readable language, right? So it converts the unstructured data into computer readable language by following attributes of natural language. So machines employ some complex algorithms to break down any text content to extract meaning from it. So that is really required, right? So we have to get the meaning of it, right? So the collected data is then used to further teach the machines the logics of natural language. So the natural language processing uses two kinds of analysis. Say one is about syntax, and the second one is about semantics, right? So the natural language processing uses several algorithms to follow some grammatical rules, right? So it uses some grammatical rules which are then used to derive meaning out of any kind of text content. So like we can see like a lemmatization, morphological segmentation, word segmentation, part of speech tagging, parsing, stemming, sentence breaking. So we will be trying to understand each and everything, right? So this is basically the syntax. The second one is about semantics. So this is comparatively difficult process where machines try to understand the meaning of each section. So semantic means it is about the meaning. It tries to understand the meaning of any content. It could be both separately and in context. So even though semantical analysis has come a long way from a binary disposition, there is still a lot of room for improvement, right? So the major thing is about NER. NER means named entity recognition. It is one of the primary steps involved in the process, which segregates text content into predefined groups. So word sense disambiguation is the next step in the process. So it depends upon the contextual meaning, right? So this is what we are going to understand, like why natural language processing is important. we all know that the data is being generated every day, and as we discussed, 80% of the data is most of the time the unstructured data. So NLP enables computers to read this data and convey the same in languages humans understand. Say it could be, we may have some medical record, unstructured data. Let us see some example for that. It could be medical records. So sometimes like a government data, like census data, or something like that. So most of the times these kind of data are unstructured, right? So say, for example, you're writing some feedback about the product that you purchased from a particular website, right? So once that is being done, the computers analyze these text and speech to extract the meaning of it, right? So people sometimes ask me why the advancement is required in the field of NLP. So please try to understand that NLP is the process of enhancing the capabilities of computers to understand the human language. So when we talk about the databases, always it is of the structured form of data, right? But unstructured data, most of the times the data we take from internet or almost unstructured data. So in such case, understanding human language, and we have to know, we have certain goals. Say, for example, Alibaba voice assistant, we must have heard about it, right? So there, we try to master non-linear conversations. Non-linear conversations means which is something related to humans' manner of communication. So, say, for example, we are talking about one thing in first sentence, and suddenly we try to talk about the next, then we come back to the first topic, right? So the person listening to this understand the jump, but how the computers will understand, right? So this is why we really give more importance to this field. So nowadays, if you look into this NLP professionals are in lot of demand. So I can tell you for sure that once you once you master in NLP, you will be getting a lot of opportunities over here. And because as I told you, unstructured data has lots of information, and that can help companies to grow and succeed. Say, for example, when you monitor tweet patterns, that can be used to understand the problems that is existing in the societies, and it also can be used in the time of crisis. So understanding and practicing NLP is surely a path to get into the field of machine learning, right? So in case if you look into the applications of few more applications of NLP, I can say Grammarly, if you see, it could be used in MS Word or Google Docs or anything, right? So search engines, or it could be used in voice assistants, news feeds, translation systems. So there are many more, right? So when you desire to study NLP, you should have programming knowledge in Python, Keras, right, and then NumPy. What I try to say over here is you should also learn the basic of how to clean text data, manual tokenization or NLTK tokenization, right? So there are several models that we will be coming across soon, right? And also we have to be familiar with some open source like NLTK, and then Stanford toolkit, right? Stanford toolkit, and then GenSim, and then OpenNLP, right? Okay, fine. Hope this is clear, right? So let's try to understand pre-processing in NLP over here. First of all, let me tell you that what is text wrangling means. We call it as pre-processing or wrangling, whatever it is. We are we are doing a machine readable form, and we are formatting text from raw data. right? And whenever we collect text from various sources, it may have lot of noise because these are unstructured data, right? So when we pass the data text from the various data sources, we need to make sense of the unstructured property of the raw data. So the text cleansing is used in the majority of the cleaning to be performed, right? So we know machine learning needs data in the numeric form. So we basically use encoding techniques like bag of word, bigram, n-gram, TF-ID of word to vector, so that we see to encode text into numeric vector. But before encoding, we should first clean the text data. And this process to prepare or clean text data before encoding is basically called as text preprocessing, right? So whenever we start with a task, it is always important to clean the data first. So to clean the data, in the sense we are making the data to be understandable by a machine, right? So what are the steps, they are really required to do that, right? So there may be the next question, like what factors decide the quality and quantity of cleansing? So I can say that one thing is about the parsing performance. It could be about the source of data source or the external noise, right? So what is meant by this text cleansing, right? So here, we are trying to clean the text and to remove the noise surrounding the text, and that we call it as text cleansing. Data munging or data wrangling, people use different terms over here, but anyways, like people use it interchangeably in a similar context, right? And so first, when we start with pre-processing, let us try to understand what is sentence splitter. So always, like NLP applications require splitting a large files of text data into sentences. So what will happen is always the text data could be of large files, right? So what we want is, like, we want to convert it into meaningful data, right? We have to convert it into meaningful data. So how it can be done? It can be the large files of raw text can be broken into small sentences, right? So a sentence is the smallest unit of conversation. So how do we define like something like a sentence for a computer, right? So we say that sentence as the small unit, right? Sentence as the small unit. So how do we define this? So we need it because it simplifies the processing involved. So for example, the period can be used as a splitting tool where each period signifies one sentence. So say, for example, I have to extract dialogues from a paragraph, and we are searching all the sentences, we could see some special characters, or we can see some inverted commas or the double inverted commas and all, right? So a typical sentence splitter can be something as simple as splitting the string on, right? So to something as complex as a predictive classifier to identify the sentence boundaries. So what is this tokenization? Tokenization is nothing but it is defined as a minimal unit, right? It is a minimal unit that a machine understands and processes at a time. So here all the texts and strings are processed only after they have undergone tokenization, which is basically the process of splitting the strings into meaningful tokens. Hope it is clear, right? So the task of tokenization looks complex because such as like need of the NLP application or the complexity of the language itself. Say for example, if you consider English, it can be as simple as choosing only words and numbers, right? But in case if you take some Dravidian languages, on the other hand, it could be hard because of the vagueness present in the morphological boundaries between words, right? So let us understand what is this tokenization. Like, it is the process of splitting a given text into smaller pieces called tokens, right? So words, numbers, punctuation marks, and others can be considered as tokens. So we use natural language toolkit library for tokenization, And here each word is a token. So when we talk about tokenization, the paragraph can be converted into sentences. The sentence can be converted into words, right? Say, I ate an apple. So how do we tokenize this? I ate an apple. So if there are any alphanumeric characters over there, how do we handle it? And if there are any special characters like apostrophes or inverted commas, how do we handle it? Like in case if there are two word entities like New Delhi, how do we handle that, right? So these will be the questions that we try to understand in NLP, right? Fine. The next thing is about the stop words. So what are stop words? Stop words are the most commonly occurring words. Say, for example, I'm asking like, how are you? So R could be stop word here, right? So it does not add any weightage or meaning to the sentence. So just it is working as a bridge, and its job is to ensure that whether the sentence is grammatically correct or not, right? So it is the most commonly used pre-processing step in NLP application. So I think like removing the words that occur commonly in the corpus is the definition of stop word removal, right? So majority of the articles or pronouns are called as stop words, right? In case like if you perform a task of information retrieval or classification, these cannot be affected by stop word. So stop word removal is not required in all the cases. But on the contrary, NLP application stop word removal has a major impact, right? So like the stop word list for a language is a hand curated list of words that occur commonly. So stop word lists are mostly available online. Like a simple way is to make use of the words document frequency, right? So word presence across the corpus is used as an indicator for classification of stop words, right? So how does this stop word removal help? What are some of the alternatives for stop word removal? That and all we have to think about it, right? So the stop words are the most common words in a language, like the me is to all, right? Do you think it has any meaning? No, actually it is working as a bridge or to fill the gap between the words in a sentence, right? So we can remove the stop words using a natural language toolkit, as I said, articles like and common verbs like is, was, where, are, pronouns he, she, it, conjunctions for and, prepositions on and with. So these are basically some examples of stop words, right? So now let us try to understand what is normalization. Say we have to, we may want the same token for different forms of the word, like say, if you take book or books, both of them are giving the same meaning to us, right? So in case if you consider both tokens in the single one, say book, books into book, talk, talks into talk, so that could be really helpful, right? So that's basically called as normalization. Right, so the next one is about stemming. So what is this stemming? Stemming means it is a process of obtaining the root form of the word, right? So here there are certain rules using that all tokens can be cut down to maintain or to obtain the root word. It is a rule-based process. So here we club together variations of the taken. So let's say that, like, okay, so I take an example like study, right? It could be studying or study. So anyways, it is going to give the same meaning as I told in the last slide, right? So it does not make sense to differentiate between the two, right? So we use stemming to club both grammatical variances to the root word. So it is in use for its simplicity, right? But in case of Dravidian languages with many alphabets and thus many more permutations of words possible. So the possibility of the stemmer is identifying in the rules is very low. So in such cases, we use lemmatization instead, because it is a robust, efficient, and methodical way of combining grammatical variation. So we will look into the differences of both. You can see here, like when you do this stemming, what is happening? People is changed to PEO, PL, saying is changed to say, says is changed to say, and the components is converted into component, and paid is changed to pay, says is again say. So if you look into the says, saying has converted into say, and troubling is changed into TROUBL. So if you look into this, you can understand that there are okay, say, pay, those are meanings. But again, if you look into this compound or trouble, TROUBL, there may not be a proper meaning to it, right? So when we talk about stemmer, there are several types of stemmer, one is like potostemmer, potostemmer. There is another one called as Lowen stemmer, right? There is another one called as Drawson stemmer, and there is another one called as Crowet stemmer. See, what I'm saying is maybe very little. There are many more actually, right? So potostemmer, generally we use potostemmer a lot, and it makes use of a large number of rules and no, with a lesser morphological variation. So for complex languages, custom stemmers need to be designed, right? So on the contrary, what I'm trying to say here is there are a lot of stemmers, like snowball stemmers. We use snowball stemmers for other languages like French, German, Italian, English, Portuguese, right? So stemming is the pre-processing step. So nowadays, in the modern NLP applications, this is being excluded because it basically depends upon the domain and application of interest. When NLP taggers like a part of speech tagger, dependency parser, or NE are used, right? So let us understand what is lemmatization now. So here finding the lemma of a word is the more exact task. So you can look at the same example now. Says is changed to say, took changed to take, paid is changed to pay, saying, say, troubling is changed to trouble, right? So this is really important to understand. So what it does is it converts the grammatical or inflected forms of the root of the word. So it use the context and POS tag to find the inflected form of the word, and various normalization rules are applied for each POS tag to get the root word, right? So it is really interesting. So what is the difference between stemming and lemmatization? What would the rules be for rule-based stemmer for native language? Would it be simpler or difficult to do so, right? So we have to look into this in detail. So the basic difference between stemming and lemmatization is that stemming is converted into the root word, but again, there is no meaning for it. But in lemmatization, there is a proper meaning, right? So there are some other cases like rare word removal. So what do I mean by rare word removal? Because there could be some words which are very unique, like it could be the name of a product or brand, or like some could be like noise characters, and that can be removed, right? So say for example, like when we handle a task of text classification, there are several names which is not a feasible option to use. So we know that, say for example, Adolf Hitler, his name is an exception. So usually names do not signify the emotion, or it is not really required to do that, right? So the second one is like spell correction. So spelling should be checked for in the given corpus, because the model should not be trained with the wrong spellings, because the outputs generated will be wrong. So spelling correction is not a necessity, but can be skipped if the spellings don't matter for the application, right? So what is dependency parsing? So it is basically to identify the dependency parts of a sentence to understand the relationship between the head words. So it helps to establish a syntactic structure for any sentence to understand it better, right? So these type of structures can be used for analyzing the semantic and syntactic structure of a sentence, right? So it is not only can the passing tree check the grammar of the sentence, but also its semantic format. I told you already, right? Semantic means it is about the meaning, right? So the parse tree is the most used syntactic tree and can be used, can be generated through parsing algorithms like early algorithm, right? So any given sentence having more than one dependency parse assigning the syntactic structure, and it can become quite complex. So multiple parse trees are known as ambiguities, so which has to be resolved in order to for a sentence to gain a clean syntactic structure. So actually what we have seen is the basic pre-processing techniques, what we generally use, like tokenization, stop word, and what kind of normalization do we do, like stemming, lemmatization, right? So I hope this is clear to you.